A project title is Mitigation of Dataskew using blockchain algorithm. Abstract. In big data, logs of peta and terabytes of data clusters are need to be processed. Hadoop allows these large clusters to be processed by using MapReduce technique. In MapReduce technique, the original job will be divided among the slaves by the master, regardless of how much time the slave will be taking to process the jobs. We also implement web crawling to reduce the same. Web crawling is where we crawl the data from other websites without the knowledge of the original developers. Literature survey. Our first paper that we studied was Libra, Lightweight Dataskew Mitigation in MapReduce. The second is MapReduce, Simplified Data Processing on Large Clusters. The third is Managing Skew in Hadoop. Objective: to solve Dataskew problem, to show effectiveness of Hadoop, reduce time complexities, compare MapReduce with blockchain. Introduction. In big data, large amount of data needs to be processed. For this purpose, we use MapReduce technique, in which the original set of input will be divided into small sets and given to the slave by the master. But due to this, the Dataskew problem arises as the capability of slave varies and the master doesn't consider how much the slave is capable of doing. This is why Hadoop is important: storage and processing speed, low cost, scalability, flexibility, computing power, fault tolerance. Existing system. In existing system, the main drawback is the Dataskew, which arises in the MapReduce technique. This is because there is no pre-processing of data. Later a technique was developed where there was pre-processing of data, but it caused the original process to be delayed a lot. This is the existing architecture. Problem definition: starting data splitting among nodes, uneven capacity of slave nodes, long running jobs, pre-sampling. Our enhancement is web crawling, blockchain algorithm. A proposed system. In a proposed system, dynamic data splitting is where the process will be executed in a parallel format, and if one slave couldn't execute the whole process, it will dynamically split a part of its process to another slave. We also show the effectiveness of web crawling using Hadoop. In this technique, we delete the DDoS algorithm, denial of service. That is, if we want to crawl the resources from other websites without the knowledge of this, using blockchain technique, we can easily do it without the knowledge of the original users. In our process, we do not require any pre-run sampling process because it will be automatically integrated with the original process. This is our architecture diagram. Hardware requirements. The system requirements is Windows 7, hard disk is 250 GB, RAM 4 GB, processor i3 and above. Software requirements: JDK, that is Java Development Toolkit, J2EE and Tomcat 6.0 and 7.0 and Hadoop. This is the algorithms used. MapReduce algorithm. Here the problem data will be given to the master node, which splits the data according to the capability of the work node. Blockchain algorithm. Modules. Dataskew and its problem. As it is mentioned earlier, Dataskew causes the time to be taken by each slave to increase, as the overall output will also be increased even if one slave delays in its process due to its lack of capability to process faster. So this causes time complexities in the overall process. This is because in the previous existing architecture, the data splitting is by a static way, and as it is pre-processed and the data will be split in a static way, there is no chance of splitting the data again even if the slave node is low. Dataskew problem. Web crawling using Hadoop. The existing technique using the denial of service detection, if we try to crawl the resources unauthorized by unauthorized access, it will automatically detect our IP address and block us. Using our technique, we implement an efficient way to crawl resources residing in any server through a Hadoop cluster. Here the data can also be stored for future use. Web crawling. Data analysis by sampling and Dataskew mitigation. In our technique, a small sampling of data will also be attached to the original process. This will save our time as no pre-sampling of the whole of the data is not needed. And Dataskew mitigation is that we will reduce the amount of Dataskew in the existing system. Different approach to solve this is dynamic splitting, where the splitting occurs when the process is running. This is the sampling of jobs. The admin gives a big job where master will be given to data analysis and data split, and then finally it will be given to the slaves. Query processing using MapReduce and blockchain. Here the whole PDF format can easily be downloaded and can be stored for future use. When we need it for future purpose, it will be easily taken from the existing stored data and no need for processing it from the first. Screenshots. This is the running of the jobs. The already crawled resources, that is the computer accessories, home appliances, are already crawled resources that are in PDF format that is already downloaded before. Conclusion. Thus we designed a Hadoop cluster which can mitigate Dataskew problem. We show its effectiveness using blockchain algorithm and MapReduce algorithm in comparison. References. These are all the references that we took from the previous existing papers.